To another day 9 challenge. Everyone, welcome to another day 9 challenge in the LeetCode. So today's problem is minimum stack. So guys, before I begin, I would like to ask to like, share and subscribe to my channel. So that's the only thing which keeps me motivating to make more videos. So please show your support to my channel. So without any further delay, let's get started with the problem. So the problem is minimum stack, which is we have to identify the minimum element present in the stack data structure. So in order to understand what is a stack, I will give you a high level overview of it. So stack is basically a linear data structure which follows LIFO. So LIFO is something last in first out. So whatever the insertion and deletion of the element has to happen at the same end. So and it has some of the properties like push, pop and top. In Java it is peak. So these are the regular properties that a stack data structure contains. But what this problem expects us to retrieve the minimum element present in the stack. So this is something additional functionality that we have to implement in this problem. So there is an example present in the LeetCode for this problem. So they are initiating an object. So this is how we operate on a stack. So we just call the push operation with the element that we want to insert, and it will be stored in the stack. So in the same way the other elements has been inserted into the stack. So this function has to return -3, which because it is the minimum element present in the stack. And whenever you do pop, so the pop operation will actually remove the element from the top. So these are the examples of the stack. So let's say you have a books or the plates which are sequentially organized and placed from bottom to top. So if you want to pick the element which is in the last, you have to remove each and every plate from the top, then only you will be able to pick the last one. So that is how the stack properties are. And top operation is something it gets an access to the last element and returns you the element present in the stack, but it doesn't remove the element from it. So this is one of the major difference between pop and top. So we have to implement this particular function. So let's get into the approach. So guys, this is the approach that I have been following to implement this. So I am going to use list implementation of stack within a constant time. So there are other ways to implement stack, which is using dequeue in the Python, but I am choosing to implement it using a list. So LIFO structure, as I like I mentioned, it is just the last in and first out structure. The first step would be to create an empty list and minimum integer variable with int value. So this once we create this, we make sure in the push operation we will try to check we have few conditions to check how can we retrieve the minimum integer value. And in the pop operation as well, we have few checks over there with if condition, and top it gets an access to the top element and doesn't remove from the stack, and get min will be returning the minimum integer value. So let's go ahead with the step 1 and implement it, and we'll go with the same process for the further steps. Alright, so this is the init. Here I'm going to create an empty list, and I'm going to create minimum integer variable using the maxint function. So why maxint function? Maxint function will return you the biggest number available. So that can be useful to help us to have the track of the minimum integer value. So going forward, I'll explain what is the importance of this minimum value variable. So the next function is implementing the push. So in push, we get the input, the element. So we check if x is less than the minimum integer value. So this is how we check it. If the condition is satisfied, we have three sub steps. First step would be to push the integer value, and the second step is to update integer value with x, and finally we push the x value into stack. So just to clear out things, this will be something like stack. Okay, so let's get into the push function and implement the same. If x is less than, so guys, most often this condition will be satisfied in the for the first iteration, for the first element, sorry, because minimum value contains a very large number. So any element, in most of the cases the probability is higher to get this condition satisfied for the first element. So if the condition gets satisfied, I'm pushing the minimum value, then I'm going to assign the minimum value with the input that we got, and finally we are going to push the input parameter. So this is the push operation, guys. So we have implemented successfully the step 2. Now the step 3 would be check if the last element is equal to, if you want to remove the element, we have to check whether the last element is equal to the minimum integer value. If the condition is satisfied, we have to follow two steps. First would be to remove the last element within an if statement, and then remove the subsequent element and assign to the minimum integer value. So let's do this in programmatically. Last element in the stack value is equal to min value, then I'm going to assign the next minimum subsequent value to the pop element. So once I do this, we are good with the step 3. Step 4 is just to access the top element and return it. So there is not, so no more conditions here, we just have to return the last element. So the get min function as well, we are going to return the minimum value. All right, so let's try to run this and see the output. So the solution has been accepted. Let's see the runtime of the program. So guys, so the main objective is to get the minimum element. So there is an example that I'm going to illustrate. So initially we store the max int value, then the first element that we have received from the in the push operation, then the subsequently we are going to add it. So this will be our final stack. So initially it would be -3 as our minimum integer value. If we perform a pop operation over here, so in the pop operation we have this if condition. So that if condition is going to remove -3 from if statement, which is from the line 78, then it is going to remove -2 element in and assign it to minimum integer value. So this will be the stack remained after the pop operation, and the output will be -2. The bottom line of this program is it will copy the elements and maintains or tracks the minimum integer values in the order, so that when pop is performed, it can have the next possible minimum integer value in the stack. So let's understand this through a diagram. So this is the stack which is available in our program. So initially it will insert the max int value, then it followed by all the other push operations that we perform. But what minimum integer value will do for this stack is it is going to keep a track of next possible minimum integer values available within right next before to it, so that if the pop or operation is performed, it will return the -2 value. So initially the minimum integer value is -2, but when it has come across the value -3, it is going to assign -3 as the new minimum integer value, and it copies the -2 element right next before to it. And once the pop operation is performed, it will remove all the top two elements and assigns the top second element to the minimum integer value. So this is how it works. So I hope you are able to understand the approach that I have described over here. So this is it for this video, guys. If you are visiting my channel for the first time, I would ask you to like, share and subscribe to my channel if you like them, and please provide your feedback on the comment section and if you have any questions as such. So thanks for watching. See you next time.